Yes, sir. Good afternoon, Mr. Bellamy. Would you turn to the staff report, please?
Okay.
Page 67.
Yes.
Or I'm sorry, let's go first to page 36 of the staff report. All right, directing your attention to the top of the page under blade shear, you notice that the first sentence states that blade shear occurs when a wind turbine blade or segment separates from the rotor and is thrown or dropped from the tower, correct?
Yes.
Okay. And is that your understanding of what blade shear is?
Yes.
Other than the information provided by the applicant in the application in this case, did Republic Wind provide you with any other information concerning blade shear?
You're saying outside of the application narrative?
Yeah, or outside of any of the exhibits or the narrative of the application.
I don't recall. I don't recall asking a data request on blade shear, but there could have been a data request to another, or I'm sorry, a response to another data request that could have included blade shear information, but I can't recall.
The second sentence on page 36 of the staff report states that the applicant asserts that past incidences have generally been the result of design defects during manufacturing, poor maintenance, control system malfunction, or lightning strikes. You see that sentence?
Yes.
And you wrote that sentence?
Yes.
Did you do any research as to what past incidences there may have been of blade shear that you're referring to in this sentence?
Yes.
Okay. What research did you do?
I look for studies on blade shear. For example, a study done by the firm Garage Hassan that cites these things that the applicant cites, and that's a generally referenced study on blade shear.
Mm-hmm. Did you learn anything concerning the distances that blades or segments of blades have been known to travel from the turbine during those incidents of blade shear?
There are some studies on ballistic models on how far a blade can be thrown, and they vary. It's a difficult calculation to perform because there's so many variables that go into blade shear. You have to take into account the mass of whatever is breaking off, the shape, the wind conditions, the speed at which the blade is turning. Some studies and some physics departments have tried to come up with a model, but I have not found one that is that's reliable and that has been used for other jurisdictions in trying to determine how far a blade can be thrown.
Mm-hmm. Well, have you come across any information concerning how far blades or blade segments have been thrown?
Yes, I'm aware of the instances that have happened in Ohio.
Okay. In those instances in Ohio, how far have the blade blades or segments of blades been thrown?
In Tempero 2, which I believe was in 2012, there was an instance in which a blade actually collided with another blade, and both blades broke. And I believe the furthest piece of blade found was 760 feet or so from the turbine base. Another instance was Hog Creek. That was, I believe, April of 2018. That was a blade that came off due to a lightning strike, and in that case, the blade fell to the right by the turbine base. And the third one is Blue Creek, which happened in, I think, August of 2018. And in that case, the furthest piece found was, I believe, 250 feet, and the applicant told us that no pieces have been found within 520 feet or so. So those are 3 instances, in Ohio.
Are you aware of instances in which it has been reported that segments of blades outside of Ohio have traveled as far as 1,640 feet from the turbine tower?
I'm not aware of that.
Well, did you do any research to find out how far turbine blades or segments of turbine blades have traveled outside of Ohio?
Yes, I've tried to find other instances of blade shear and data on how far they've been thrown, but evidence is very lacking, and the incidences are usually not well reported.
Are you aware of an internet database called the CAFNIS database of turbine incidents?
I am aware of it.
Yeah. Did you review that?
I did.
Okay. Did you see instances reported in that database of turbine blade segments traveling as far as 1,640 feet?
I don't remember that. I mean, it could be in there, but I don't remember every instance that is in that database, and I can't verify the accuracy of that database.
Directing your attention back to page 36 of the staff report. In the first paragraph on that page under blade shear, there's a sentence that starts on the 5th line with the words "the turbines." Tell me when you found that sentence.
Yes.
Okay. Now it says in that sentence, the turbines have the following safety features to address blade shear: 2 fully independent braking systems, a pitch control system, and turbine shutdown at excessive wind speeds and at excessive blade vibration or stress. These safety features and the use of setbacks minimize the potential for blade shear impacts. Did you see those 2 sentences?
Yes.
And you wrote those sentences, right?
Yes.
Okay. How long have these safety features been available for turbine models on the market?
I'm not sure, but I would say at least 10 years. Garad Hassan published a study in 2007 in in which they cited that blade shear incidences have gone down due to the implementation of the safety features that I mentioned here. So it's been an industry practice at least 10 years.
And how long ago did the blade shear at the 3 Ohio turbine facilities occur?
Well, 2012 would have been 7 years ago, and 2018 would have been last year.
Okay, and what about the third one?
That's what 2018 again.
Stay on that page and also go to the narrative of the application.
What volume is the narrative?
It should be in the binder marked December 26, 2018, and it would be the first part of the
1 of 3?
application.
Okay.
All right, go to page 83 of the narrative.
Okay.
Now let's just go to page 84 of the narrative. And we'll start with the first paragraph at the top of that page. Starting with the first full sentence on the first line on the top of the page 84. That sentence reads, "It is anticipated that the wind turbines to be used..."
I'm sorry, I'm not on the same page as you.
So I think we're running into the problem of he's using the redacted version, and I think you're referring to the unredacted
Yes.
version. So,
Can you cite to the section?
Section is it's 4906-4-08 under blade shear.
I see a heading blade shear.
Okay. Then go to the third paragraph of that, under that heading. And tell me when you find the sentence, the first sentence that starts with the word, "it is anticipated."
Oh, yes, I see it. Is it anticipated?
Okay. And that sentence reads, "It is anticipated that the wind turbines to be used for the facility will be equipped with 2 fully independent braking systems that allow the rotor to be brought to a halt under all foreseeable conditions. In addition, it is anticipated that the turbines will automatically shut down at wind speeds over the manufacturer's threshold." You see those 2 sentences?
Yes.
Okay. Now, you were the staff's reviewer for this section under blade shear, correct?
Yes.
Okay. And I'm wondering whether you regard it as anticipated that the measures in those 2 sentences will occur is the same thing as an enforceable requirement that the equipment necessary to implement the anticipation in those sentences is actually required.
Objection, compound question.
Can you break it down, Mr. McLeod?
Yeah. Based on these 2 sentences and their use of the word anticipated, is it your belief that there is any requirement in the application that the systems described in these two sentences actually be installed?
It's my understanding that the safety systems that are mentioned here are standard safety systems on modern wind turbines. So it is our understanding that they will be included.
Is there anything in the application, though, that requires them to be installed?
I think so.
Okay, where do you see that?
The wind turbines are going to be certified to certain wind classes and by a certification body such as Germanscher Boyd. And that certification requires that certain controls be implemented and certain safety features be included. And if the turbines adhere to those certifications, then they will have these safety features included in them.
Okay, can you point to language in the application saying that the turbine models that are used for the project are going to be certified?
Yes, if you go above the glacier section to the prospects of high wind in the area, this section talks about international standards and that all turbines are under consideration are designed to meet the standards and are rated to specific IEC wind classes. So yes, all the turbines will be certified.
Well, based on that paragraph, isn't it true that this paragraph only talks about certification of the turbines with respect to winds?
Well, the wind classes they do vary according to wind speed. But the certifications are more than just wind speed. The certifications go into how the turbines are manufactured and the testing that goes on and the safety features that are incorporated into the turbines. So it's more than just what wind speed the turbine is designed for.
This paragraph doesn't require any certification for the installation of braking systems, does it?
I don't see braking systems mentioned in that paragraph, although the safety features of the turbines are part of their certification.
Isn't it true that in the past, the board has required wind turbine projects to install braking systems as a condition of their certificates?
I don't know, but I think that's correct that, you know, previous cases had included a condition like that.
The staff's recommended conditions for this case do not include any requirements to install braking systems, do they?
Well, condition number 1 says that the applicant has to, hold on a second, let me go to the conditions in the staff report, so I know exactly what I'm citing. Okay, yes, condition 1 says the applicant shall install the facility, utilize equipment and construction practices, and implement mitigation measures as described in the application and as modified or as clarified in supplemental filings. So the applicant has to construct the facility like they described in the application. In the application, they described that the turbines will be certified, and therefore the turbines will be certified. The turbines will have to adhere to the safety features that are that the certification is required.
Wouldn't it be a good idea to simply state in the conditions that braking systems have to be installed to make sure that they're actually installed?
Objection. The witness has answered this question. He just hasn't answered it the way that the attorney would like him to.
I don't think he's answered the question at all.
He's only answered it 3 times.
I'm asking if it would be a good idea to make sure that the conditions clearly require braking systems to be installed. It's a new question.
Just answer the question.
I am confident in the applicant's assertion that the turbines will be certified and therefore will have the safety features that are included in the certification.
Let's talk about shadow flicker for a little bit. You reviewed the application's information about shadow flicker, correct?
Yes.
And you know as a result of your review that the application represents that the Vestas V150 produces the most shadow flicker, correct?
Yes.
Okay. And that's based on the fact that this is the model that is identified in the application as having the widest rotor?
That's correct.
Okay. Now, there's another model that is also included as a possible turbine model for this project that's taller than the Vestas 150, correct?
Correct.
Okay. Did the applicant model the shadow flicker from that turbine model?
I can't remember, but I think they modeled, well, before the June 2019 supplement, which added the SSV V136, I believe the only turbine model was the V150, which is the worst case scenario turbine.
Well, if you can't remember whether and then later there was another turbine model, at least one other turbine model, added to the array of turbine models that the applicant states that it might use for the project, right?
Yes, I just mentioned that.
Yeah. And one of those models, I believe, was the Nordex N149. Is that correct?
Oh, I'm sorry, what is your question?
Let's simplify this a bit for you. Go to Company Exhibit 1E, please, which should be in the binder in front of you. Yep.
Okay.
All right, go to page 1 of that document. And I'd like to direct your attention to Table 1.
Okay.
All right, and Table 1 includes 3 turbine models that the applicant is considering using for this project, correct?
Yes.
One of those turbine models is the Nordex N149, correct?
Yes.
And the maximum total height for that turbine model is 602 feet, right?
Yes.
The maximum height for the Vestas V150, according to this table, is 591 feet, correct?
Yes.
Okay. Now, then, does this refresh your recollection as to whether or not the applicant modeled the shadow flicker from the Nordex N149?
Well, like I said, I don't think it did.
Okay. All right. So, isn't it also true then that the greater the height of a turbine, the more shadow flicker it will cast than another turbine that is shorter but has the same rotor length or rotor width?
Maybe depending on the terrain, but in general, no. The differences in height and shadow flicker, there's 3 things that produce shadow flicker. You have the sun, a turbine, and a receptor. If the turbine is taller, the sun is still going to have angles of attack on the receptor, no matter what the height is. So the biggest factor in considering shadow flicker is rotor diameter, and the Vestas V150 is 1 meter wider, and therefore has I think 20,000 square feet extra area that it casts a shadow. So that 20,000 square feet produces a lot more shadow than an increase of 9 feet, which is the difference between the Nordex 149 and the Vestas V150.
Well, isn't it true that shadow flicker occurs as, in the evening at least, as the sun is sinking down towards the horizon and to an elevation where the turbine blades are turning between the sun and the receptor?
Yes, the sun has to be low in the sky for shadow flicker to occur.
Okay, so for a taller model, a taller model will be between the descending sun and the receptor earlier than a shorter model will, correct?
Yes, like I said, the difference would be slight though. The area that we're talking about for between the 149 and the 150 meter rotor diameter is a very large area. So yes, if the same rotor diameter, a taller turbine may produce a little bit more shadow flicker, but the larger rotor diameter is going to produce a lot more than the smaller rotor diameter.
Have you ever seen a shadow flicker study that compared the amount of shadow flicker from one turbine model that was taller but not as wide as another turbine model that was wider but not as tall?
I can't recall.
Let's go to the staff report, page 67. Condition 45. And condition 45 states that at least 30 days prior to construction, the applicant shall submit a shadow flicker study showing that cumulative shadow flicker impacts will not exceed 30 hours per day at any non-participating sensitive receptor, correct?
Yes.
So at the present time, the applicant has not submitted an array of turbine models that demonstrates compliance at all non-participating sensitive receptors with the 30 hours per year standard, correct?
Yes.
Let's go back to the application narrative, page 85.
Okay.
I'd like to direct your attention to, actually it's just one page or maybe 2 pages at the most past the section we're looking at on blade shear. And we're going to look at the section on ice throw.
Okay.
Under ice throw, go to the 4th paragraph.